Adding vector by component. In the previous section, we have learned how we can add vectors using graphical method, either head to tail or tips to tail, or using parallelogram. All of these methods require proper scaling of our vector to the right magnitude and right inclination angle, which all of these may be cumbersome and may not necessarily be precise. But for us to get an accurate and be able to solve more complicated vectors summation or subtraction, we use what we call vector components. What do we mean by that? Suppose we have a vector in the y direction depicted as our AY, and we have another vector pointing towards the x direction as AX. The line at the center is the resultant. If we join this together, we have our parallelogram, or we have our square. So the component of AX and AY is given as A cos theta, and along our y direction is given as A sin theta. How do they get that? Look at this triangle. We have a right angle triangle here, and if we use our trigonometry that we know, which is our SOHCAHTOA, we have for our AX, that is A cos theta. So what we have here is that when we consider cos, which is adjacent, our adjacent for this triangle is AX. So we have our AX, which is equals to adjacent divided by hypotenuse. Our hypotenuse is A, and this is our cos of our angles, theta. If we cross multiply, what we have here is AX is equals to A cos theta, and that is where they get that. The same applies here. When you consider the sine angle of this triangle, we can get our opposite from this triangle, from this rectangle here. This is the same thing as AY, A subscript Y. And if we consider the triangle this time around, the sine angle becomes sine of the angle, which is the opposite, which is our A subscript Y divided by the hypotenuse A. So we can get our AY to be sine angle theta A. And this is how we obtain this. So now that we understand the component along AX to be A cos theta, and the component along Y to be A sin theta as given in the lower figure. So we can therefore say that the equivalent of this could as well be Rx or Ry equals to either R cos theta or R sin theta. So how do we find the resultant? The resultant, we use our Pythagoras theorem to obtain our A, and we can obtain our angle function using tan. You understand that tan of our angle is theta, right? Which is opposite, which is our AY, over adjacent, which is AX. And this is the way we can obtain our angle. And when we take your tan inverse, then we can get your theta. So to get the magnitude of our resultant, we applied Pythagoras theorem, which is going to be A squared equals to AX squared plus AY squared. This is how we get our magnitude of the resultant vector A. Okay, like I said earlier, we can find the tan to obtain this expression, and if we are to get our theta, as the question may ask later on, we are going to take the tan inverse of AY divided by AX, and we already know what AY is, which is A sin theta, and we know what AX is. Component along x-axis is A cos theta, where A is our vector. Sometimes our dimension may involve a third component, which is our z component, and for that reason we include our z component here, and that's how we got this expression. Let's solve another example and let's apply what we have learned so far. The question says there are 5 coplanar forces which are shown here in this figure, and they are all acting on an object. The task before us is to find the resultant vector. So what do? Step 1, we need to list out or resolve the vector along x component and y component. We already learned in our previous section that ax, that is the force along x-axis, or we may decide to use F for instance. Since we are talking about the force, we can say Fx is equals to force along the x component, which is given as F cos theta, and our Fy to be force along the vertical component, which is given as F sin theta. So the first thing we are going to do is to list out all the forces. So these are first force 19, we have it here. And these are second force, which is 15, we have it here too. And these are third force, which is 16, we have it here, that is 3. And these are next force, which is 11 newtons, we have 4. And these are last force here, which is our 5. So how can we now use this formula to relate these forces together? Let's take a look at it. Our initial force 19 is making angle 0 to the x-axis. So if the angle is 0, what will be my force? And we know that cos 0 is 1. So this one becomes F, which is our force, which is 19 times cos of angle, which is 0. Here I have applied this formula. Okay? And cos 0, which is the angle here to the x-axis, is 0. Cos 0 is 1. Therefore, 19 times 1 is 19. Let's look at the same force along our y-axis. Since we said that the angle it makes with the x-axis is 0, therefore 19 sine, using this formula, 19 to represent my force, sine of this angle 0 is going to be 0 because sine 0 is 0. That's how we get our 0. Let's look at the second one. We have our formula as F cos theta. For the 15, since our force is here, we have our force, which is 15 cos of the angle here, given here as 60. And 15 times cos 60 will give us 7.5 Newton. Let's look at the equivalent of that along our y-axis. We use this formula, F sin theta, which is 15 to represent our force. These are our force here. And we have it like so, which is 15 sine 60. And 15 sine 60 give us 13 newtons. Using the same formula of Fx equals to F cos theta, let's look at our force along the x-axis for 16 newtons. Now there's something you should take note here. On our x-axis, anything towards this side is positive and anything towards this side is negative. So let me change my marker to represent our sign on our y-axis. Anything, suppose this is 0, anything to the right of 0 on the x-axis is positive and anything to the left of our 0 is negative. However, for our y-axis, anything at the top of 0 is positive and anything below 0 is negative. So putting that in mind, if we are to resolve our force along 16 for x-axis, this is going to be negative. So So this is where we get our negative. Then we have our 16 to represent our F, then our cos of the angle, which is 45. On our y-axis, but it's going to be positive since it's at the top of 0. So we have our 16 here, but the angle is sine 45 to give us 11.3 newtons. Now, our first 11 newtons is below 0, so we have negative. So that's why we have negative, and we use our formula F cos theta, which is force here is 11 newton, cos of the angle here is 30, and this gives us minus 19.53. How about this 11 newtons on the y-axis? 11 newton is below 0, so it's going to be negative. That's why we have our negative, and it should be F sine theta. Our F here is 11, sine of angle is 30. So we have minus 5.0 newtons. Now, let's look at the force 22. The force 22 is perpendicular to our x-axis. The angle is not given, but we know it's perpendicular, and perpendicular is going to be 90 degrees. So therefore, our formula for this becomes F cos theta, and our F cos theta here becomes 22 cos 90. Cos 90 is 0, that's why we have 0 newtons for the force perpendicular, force 22 perpendicular to the x-axis. However, on our y-axis we have F sine theta, and F sine theta here means what? Means that our force here is 22, but it is minus because it is negative. It is below 0, as we are earlier discussed. Therefore, sine of angle here is 90, and sine 90 is 1. Therefore, minus 22 times 1 gives us 22. I hope this table is now very clear, and this is how we resolve force component or vector component. If we continue, we can find the resultant by calculating the vector component, the sum of this vector component along x-axis and the sum of these vectors along y-axis. So if we sum all these together, 11, 13, 13.0, 11.3 minus 15, we are going to obtain minus 3.2 newtons, and that is what is worked here, and we call it our vector component Ry or Fy. Okay, and also we can sum all this together to give us 5.7 newtons to give us our Rx. So therefore our Rx is the sum of all the vector components along x-axis, and Ry is the sum of vector components along y-axis. And this here represents the sum that we've done on the table. Now that we have our Rx and our Ry, to find the magnitude, which we've learned that we're going to use our Pythagoras theorem, has to be with R squared equals to Rx squared plus Ry squared to give us 16.5 newtons. Now, if the examiner equally asks us to calculate the angle, so finally, since we get our resultant vector to be 16.5, so we can therefore say that from here we have 5.7 to be the vector component along Rx, and this is Ry, which is vector component along Ry. The negative here indicates downward, something less than 0. So with this, we can get our right angle triangle here, and this is the phi we are asked to calculate. Our R is already known, which is 16.5, as we have earlier worked, newtons. Therefore, we can use our tan of the angle, and we know that tan phi is equals to the opposite, which is minus 3.2 newtons divided by the adjacent. The adjacent here is 5.7 newtons. And if we take the tan inverse, we have it like so, because 3.2 divided by 5.7 is 0.56, and the tan inverse here has given, and we have 29 degrees. This brings us to the end of this unit, and in our next video we shall be talking about how we can find the product of our vector and scalar quantities. See you in our next video. Thank you.